Greetings to all. Myself R. Surivel, and I am with my team here to present an project IoT based alcohol detection system. We are very proud to present this project because this project fully utilizes the properties of the IoT technology to provide us with an innovative technology which focuses on bringing out the goodness and intensive care in the emergency section, and it really signifies the users in the RTA patients, road traffic accident patients. We know that traditionally when we receive road traffic accident patients, we will take the blood routine or breath analyzers to find the alcoholic content in the patient's body. But this kind of traditional methods takes so much of time and it requires the active patient cooperation. But to overcome this time lap and to overcome this problem, they have invented a device which is IoT based alcohol system. With this precisely and continuously detects the alcohol and shows us in the real time through the software, so that we can monitor the patient's alcohol level from anywhere using the software. To understand deep about this project, we must first know about the components and all of this. To explain this, I call upon Vijendran.
The compounds includes a MQ3 semiconductor. The 3 is a specification of the alcohol and its derivatives, and the OLED, then the buzzer and the ESP8266. It's the thing which helps in the IoT device, and the jumping wire and the buzzer. It input of 4.5 to 10 volts and works on 3.3 volts, and it's a microcontroller of 2.4 gigahertz, and the frequency is 80 megahertz. The mechanism would be explained by Mr. Vishal.
So greetings everyone. So here we have the graphical representation of our project. So we'll start with the MQ3 sensor. So the sensor is actually made up of a metal oxidized semiconductor, which actually works on the principle of oxidation. So whenever an alcohol vapor hits over that sensor, it changes its resistivity, and so the waves are passed and the impulse is recorded. So this basically has two outputs, actually an analog one and a digital one. So digital one is actually displaying over there, and then analog one is not actually we are occupying here. So it's also connected with the ground system and uh, uh, co- and now it's actually we have a basic model which has a buzzer. That buzzer is actually a emergency system which detects alcohol and says it's an emergency detected like an alcohol. So we actually connected the project with our ThinkSpeak server, which allows us to access the detection of alcohol through from any area and whenever possible, wherever possible. So when the alcohol is actually detected, it would actually give a reading with actually parts per million and also the concentration of alcohol. So I'll show you a small demonstration. So now the device is in sober. You can see this is actually an alcohol. So now the alcohol has been detected and the sensor is the display is showing drunken, which means the alcohol has been detected. Thank you. So the further um, followed by the mechanisms, the merits will be explained by Mr. Gokul.
I'm going to illustrate the advantages of the device. This device is specifically designed to improve the patient care in emergency medicine. That is of mainly of road traffic accidents. As we all know, alcohol consumption is the main cause of the road traffic accidents. In India, generally, more than nearly 1,78,000 deaths were due to road traffic accident because of the alcohol consumption. The main advantage of this device is it doesn't require any cooperation of the patient. For example, if the patient doesn't cooperate or if he is unconscious, even we can detect whether he is alcoholic or not just by his breath. Whereas in traditional alcohol meter, we need a alcohol analyzer, breath analyzer or a blood analysis. That is the major difference between the traditional alcohol meter and this device. The other advantage of this device is we can implant this device in heavy vehicles so that we can alarm the patient if he has drunken, and we can prevent the road traffic accident. Thus, this decreases the mortality of the road traffic accidents. The other advantages is this is cost efficient than the traditional alcohol meter. Now, Rahul will elicit the disadvantage.
Evening, folks. As any device has its own disadvantage, so does this alcohol detection system has its own limitations. Since it is not a Carnot engine to run efficiently as 100%, it does come with some drawbacks. The first major drawbacks we have seen here is it doesn't come up with its own operating system, and power supply it is not independent in this operating module. Microchip processor is primitive compared to its successor Raspberry Pi, which is far more efficient to overcome the multinodal junctional relay. And the major drawback here is there is no system to differentiate what kind of alcohol people intook in times of RTA. And another major limitation is people can easily manipulate, since it is just a program, we can reprogram it and fabricate whatever the readings will be. In India, the estimated limited permit is below 30 BSE units per 100 ml of blood. So people can use it to manipulate the McNaughton's rule in India and some other countries. To summarize this, I would like to call Mr. Vinith to wind up.
But by seeing this project, you can get what's the idea about this? You can get the idea what's our project is that it's a major thing of this project. We need to reduce the RTA accidents. Road traffic accidents are main reason for due to alcoholism. Alcoholism, to reduce that, we have an idea of to make this project like that. By this, we can reduce due to the sensor, by the when the alcohol rate is been increased on the person, it will inform to the person when they are by the GPS location to the authority and the family members. By that, we can prevent something like that. And after that, when we involve this process into the vehicle run, we can by when the person's alcoholic level is more, we can off the vehicle automatically. That's our conclusion. This is our budget, and thank you.
Thank you for your valuable time.